We'll take your layout, we'll take your schematic, and we'll compare them. And if there's the same, it will tell you, so that you don't need to simulate your layout. You already know it works. So this will save a lot of time for you. This is a very important feature. It's called LVS. Okay. Now the thing here, I don't have my schematic already, so let me just create it really fast. Only take a second.
That's the only way to simulate the layout?
No, you can simulate it the normal way, which is extract the spice netlist and then take it to HSpice. Yeah.
Then at the end we will simulate it using the HSpice.
Right. Okay, so I created a schematic view of the same cell. I need to place NMOS and PMOS. Sorry, it's the devices here. By the way, the layout that we just created is the low threshold transistor, VTL. If you compare it with a VTH or VTG, it will tell you it's different. It doesn't match.
Their threshold voltage?
Yeah. It's low threshold. If you want to create a high threshold NMOS in the layout, you would use different layers from here. You would use the VTG and VTH layers on top of the active layer. That's to create high threshold and general threshold. But we're using VTL here, low threshold. Now I need VDD and ground. This circuit is ugly. The nice thing about this is that if the widths of the transistors don't match, then it will tell you have different width in the layout and here. So it's better to make sure of that too.
So basically we do the schematic, then we do the layout.
Right. Yeah.
Why don't we just do the schematic?
Well, you can't fabricate anything with a schematic, right? Okay, so this is...
Is there a way to optimize the routing within the layout?
The routing, you mean automatic routing?
Yeah.
There is a way, yes, but personally I haven't tried it. I've tried it in Magic though, and it works really nicely in Magic, the automatic routing there. Okay, so what width do I have for the PMOS? You can check by using this tool, by the way. No, I'm sorry. There's a measuring tool that you can use to measure. Anyway, I have to try that. Just count it. Oh, I think it's 8, right? Created as 8. Okay, so if it's 8, then how much nanometer is it? So 8 times 50, 400.
8 times 50, 8 times 0.25.
No, 8 times 25, right? So it's 200. That's right.
I need a real.
Yeah, you'll get a plus 1. Okay, and this is 100. Okay. Warning. Okay, now I'm ready to do the layout versus schematic. I go to the layout, I go to Calibri, and I say run LVS, layout versus schematic. Okay. Now, here I need to go to netlist and tell him to export from the schematic. So that, because I don't already have my netlist there. So this is the only thing I need to do, and then just say run LVS. Now here you either get a smiley face or you get a sad face. Here I think I got a sad face. Oh, what?
Use 5. You should have 40 use 5.
Oh, let me check. It will tell you anyway what's the difference, so. Here you mean?
You need to use 125.
Oh, I need to do 125. Let me check the report I got. I have a discrepancy. Oh yeah, you're right. See here, it tells me that one of the NMOS is 125 and one of them is 0.1. So the layout one is 125. Good catch. So I can either change that or change this. So I'll just change that.
Smile. Before the smile.
Yes, we got a smiley face.
The light and the tongue.
Okay, so the design matched perfectly. That means if I know that my schematic works, I'm sure that my layout works. Now, the only part that still needs to be verified here is that your schematic will not generate parasitics, right? So that's the only part that you need to check in your layout. That's why you need to extract the netlist from the layout and then use HSpice to simulate the layout with parasitics. Because some circuits fail to work entirely with parasitics inside of them. They may work in schematic but fail. And here that, by the way, everything should be the same. The port, the pin names, they should be the same. The widths, the connections, everything. Okay. And this ends our lecture today. Is it hard? Have any questions?
We need as much as labs, but as list as homeworks.
Less homeworks?
Yeah.
We only
Much
had one
less
homework.
and less homeworks.
Yeah, this, I think this ends our cadence labs. But let me tell you quickly how you can generate your netlist. Remember here in the, I'll have that in the PDF tutorial anyway, but let me talk about it quickly. Here in the LVS, we told the software to export from schematic viewer, and this is the file that it exported, the netlist from the schematic. Now I need this file to generate the parasitic netlist, which I get from running this. It's parasitic extraction, PEX. I'm not gonna go over that, but the result of this will be a spice file including the parasitics, much the same way that you have in Magic. And then you simulate that in HSpice on the command line. So here you tell it the netlist file, and you select what parasitics you need to extract. You can select no inductance, transistor level, gate level. I'll have that in the tutorial anyway. But
So this is
that's
all
about
from
it.
the schematic, right?
yeah, no, the parasitics will come from the layout, but you need the netlist of the schematic that you generated from the schematic. Okay.
But is the file that I generate is a netlist or HSpice file? Because I know that
It's the same.
netlist
The same.
is maybe different.
The same. The HSpice file is a netlist.
Consider it as netlist.
Yeah. Of course, it doesn't have any simulation commands or anything. You have to add that to it later. Next lab session will be probably concerning Verilog. We won't go over everything Verilog, just a introduction. You guys have to do most of the work if you don't already know Verilog or VHDL. Just have a small introduction, and you guys should read tutorials on your own time and get familiar with it.